Okay, this is the last video in our three-part series here, just talking about basic surveying principles and the general idea behind surveying some of the basic things we need to as a company. Again, this is outside the bounds of our full survey for our design, but these are basic needs sometimes we need to do and go out and do ourselves. So again, we mentioned the three primary needs we have is surveying a road or a ditch profile, surveying cross sections, and shooting a flow line or ordinary high water mark elevations. So in the last video we went over the differential leveling exercise, and that pretty much provides the full foundation for all of these types of surveys, for all the things we're going to be doing here and discuss it. There will be a few little variations as we move into it, but it's the same general principles, and if you know that and you understand the data sheet and how to present that and calculate that, that will get you everything you need to know for these. Okay, so the first one we're going to talk about is surveying a road or a ditch profile. Again, it's just a simple differential leveling exercise. However, there's no real specific benchmark 2 that we're looking for. We just shoot multiple foresights to points along the center line at specific distances, which we'll call stations. We generally always have a specific benchmark, which we start out with, that sometimes it's a point of known elevation, or it's an assumed point of elevation, or just essentially a starting point. So it can all be relative to itself. So there may not be an actual elevation above sea level, but it's all relative to each other. Okay. And so, again, thinking about what we need to do in addition to just regular foresights, the variation in topography distance will determine any need for turning points and the number of instrument positions. Sometimes if it's a really flat road, you can go a pretty far ways down. The problem is just the limitations of the instrumentation. Even the laser level, even though it's a laser, can only go so far. So you may only be able to get 500-600 feet at most down the road before you need to move the instrument, purely because the laser just can't reach that far. And the signal starts to wear out. And then sometimes you'll get into situations where it's really rolling topography, and you have to change instrument positions constantly because you can only set the tripod up so high, and the rod only goes up 14 feet, and at which point it's incredibly unstable. So generally you're limited to about maybe 10 feet of elevation change before you'll need to really think about changing the instrument position. So again, the equipment needed, we have our basic laser level. Essentially, it's got a tripod set up, the laser level screws on, and again, we're just going to set it up, get the tripod as level as we can get. The laser level is self-leveling, and then we have our rod with laser target. We have a wheel, and then we have our data sheet, which for this exercise it will just be a simple differential leveling data sheet, so nothing extra there. So in this example, we're going to assume, just for ease of example, that we're not going to need any turning points here. If you look, we're going to set up our instrument about halfway down on a little bump here, and so it looks like our line of sight should be able to get the full distance. We're only shooting 300 feet, so it should be able to do that pretty easily. And we're going to get out there basically and say we've got a specific starting point. There's a say a traffic light or something at the top of this hill, and that's our beginning point. So we're going to set that as our first station. And again, if you're not familiar with stationing, it's basically the distance. We just basically put a 0 plus 0, 0. So the first 0 before the plus is a hundredth, and then afterward are just digits. So here we go from 0 distance to 100 feet, represented as one station, so 100-foot station, and 2 plus a pair and 3 plus a pair here. That's just kind of the engineering nomenclature which you'll see typically presented on plans and surveys and stuff, and so you'll need to be familiar with that. So we go, and generally when we're shooting a profile, we're wanting to go down the center line of a roadway, so we're going to mark it and roll it out, and either mark all these stations. We can, if it's asphalt road or concrete, we can go and just spray paint a point on the roadway. If it's dirt, sometimes that works, or sometimes we just need to roll it as we go and shoot them. So again, first thing we need to do is to establish the height of the instrument and establish an elevation at which all other things will follow. So we're going to shoot a benchmark, and we're just saying this is where our benchmark. Maybe there's a manhole cover that we either know the elevation, or we know it's a point we can reference to establish the rest of this. So it's the only stationary point out there that we can reference. So we're going to assume the elevation of this. Say it is a manhole cover. We're going to assume the elevation is 100. And then that gives us enough room to go above or below, just in case we need it. So we're going to shoot a backside on there, and here we're saying it's 5 feet. So again, the backside plus the elevation gives us an instrument height of 105 feet. So now the process, now we've established our instrument height. And from here, it's really straightforward if you can see everything. And so now we're just going to take 4 sights at each individual station. And so again, it's a pretty straightforward. We have our instrument height. We shoot a 4 sight, which I just noted here. And then we take the instrument height minus the 4 sight, and that gives us the elevation of this point. Okay? And again, we're just doing the same thing. Shoot a 4 sight. Now we're at station 1 plus a pair. Instrument height, same instrument height, minus 4 sight gives us the elevation. Station 2, and station 3. And so same thing, straight down the road. And that's basically it for shooting a profile. Again, if you're getting that, having to change instrument positions and things like that, then you'll need to go back to that differential leveling exercise and establishing turning points and other things like that. But if you have a clear field of view, everything basically is a 4 sight, and we're just establishing elevations. And so again here, maybe the actual ASL is not that important, but we just want to know a relative elevation, so all these points. So we just want to know relatively, how does this look, okay? So now we've got our elevations, and we can compare them to each other. So the second type of survey we generally do is looking at cross sections. And again, this can be, we've had situations before where we set the surveyor to do the task, and we got them to survey quite a bit, but because of the type of project, because of specifics in the project design, we needed a few more cross sections back to really establish what was going on. But the surveys are busy, and sometimes we just can't get them back out there as soon as we need the information. So surveying cross sections. So it's basically the same basic process. We're surveying a center line profile, like we just went through. But basically, we're just at every station, we're just now going to add extra lateral survey points. So we'll still take our center line, but now we're going to move to the left and the right across the roadway in ditches and things to get this survey information. Again, basic same equipment. We have our laser leveled, rod with laser target, wheel, and data sheets. But this time we'll need an extra data sheet in addition to the basic differential leveling data sheet, which makes it easier to just mark points. And so we just have a cross-section diagram for each station. So again, we're just going to look at the same idea, and we mark our stations out. We're going to set up our instrument, and we're going to assume kind of the same scenario. We can shoot our backside to our benchmark, but note it's essentially the same data sheet here for our differential leveling. We've just added a couple more columns. So we have our station, but we want to kind of identify what point it is, whether it's the center line, it's the edge of pavement, ditch flow line, things like that. We want to know which side of the road it's on and the distance. So a note about the side of the road. So here we generally station, now in this, we go from 0 to 3. We start at 0, and as we're facing towards higher stations, left is your left and right is your left. And so left and right are as you move or increase in station. And that's the way we denote it, so it doesn't get confusing. And we generally write LT or RT for left or right. Okay. And then we want the distance to each point, which I'll reference in just a second. So again, here we start off, we want to shoot our backside to our benchmark, and now we've established our instrument height. And so now everything can be a foresight subtracted from this instrument height to establish the elevation of all the other points. So just like in the example before, we're going to take the foresight to our first station right on the center line. And so we have a station, 0 plus a pair, and the point is the center line. So note here, there is no side because it can't be left or right because it's a center line. So everything will be left or right of the center line point. And there's no distance because the distance is determined how far it is from the center line. Okay? So again, but we can use that foresight, we shoot it, and we figure out the elevation. So now thinking about each cross section. So for each cross section we shoot, so say now we've shot station 0, and we just shot the center line right here. At each point, we want to pick up quite a few different locations. Not always the same, and if there's other identifiable features, then we can go from there. But the main things we generally want to see, other than the center line, we want the edge of pavement, so denoted here on each side. And from the edge of pavement, normally there's a fairly smooth drop until you hit basically the side of the ditch, and kind of at the point where the ditch begins. So sometimes you can need, to establish the ditch if it's fairly wide, kind of each individual point there, or we could just kind of come down and say there's a flow line here. But a lot of times we want to see how wide the ditch is. So a right side of the ditch, a left side of the ditch, and then the central flow line elevation of the ditch, just to establish that. Now if it's perfectly flat, then obviously having these 2 points will work. And then from that, depending on whether it's a cutter field scenario, it generally comes back up, probably not this pronounced. And for most cross-sectional surveys, we just kind of need to know where this goes. So if it's way out here and there's nothing else going on, you can just kind of pick a point 40 or 50 feet out, depending on the needs of the survey, or at least shoot to a fence line and mark the elevation and the the distance to that fence line. And so again, we want to do that on each side, so left LT and right LT. And so you're going to need to kind of do a lot of things at once. So you'll need to measure with the wheel the distance to this point, mark it, and then you need to take the rod and take a foresight at that point. So again, like I've got written here, each feature needs to have a distance from center line and a foresight to determine the elevation. So at every single cross section, so sometimes it's helpful to kind of have a drawing, something similar to this, have a couple lines here to write each of these down, and in that way it helps you keep going as you go along. And then once you've written that down, you can come back into your main data sheet and you can fill all the information in. So what it would essentially look like for each cross section, we shoot the backside to the benchmark, establish our instrument height. Now we can shoot foresights. So instrument height minus foresight will equal elevation. So we start with the center line, and then it's still all the same station, but now we have the edge of pavement on the left side. We measured the distance. We took a foresight, which gave us an elevation. I kept these as X's just to mark basically what needs to be filled in, but I didn't want to make up numbers for each of these, just become tedious. These are kind of typical distances out for each one of these. That's why I kind of put them in here. So we can have the inside ditch side, the flow line of the ditch, the outside of the ditch, and the fence line. So all on the left side, and then we'll have the same measurements on the right side. There may be other things, other features, if there's something really unique about the area or something, but this is kind of the main things we're looking for. And again, each one of these needs to have a description of what point it is, what side of the center line it's on, the distance to that point from the center line, okay? And then a foresight, and then we get our elevations. And so we just keep repeating this process at every single station we need a cross section at. And so we'll go back, and so now we're at station 1. We shoot the center line, each one of these features, measure them out, and keep moving down. It's a little bit tedious, but it gets kind of difficult doing it by yourself, holding the wheel, holding the data sheet, holding the rod, and carrying them all down with you. But it's kind of what you have to do unless you can find a really helpful assistant. But so that's pretty much the idea behind doing cross sections. And again, as long as you don't need to move your instrument and do any turning points, you will just continue to keep shooting foresights each time. But if you do have to reestablish the instrument height and move it, again, pick a spot, a good turning point. Ideally, use something different, potentially than one of, just the center line of the roadway, a more defined thing like a manhole cover, any concrete, established, feature that is not going to move. There's a very definite point, and then you can shoot that elevation as a foresight, establish the elevation, move your instrument, then again shoot the backside to reestablish the instrument height, and then just keep moving down the road. Okay, so the last one is pretty straightforward, pretty easy. Surveying flow lines, ordinary high water mark. Sometimes, like I mentioned in the first video, depending on the type of survey, maybe the flow line is not shot very well, it's buried, there's something wrong with it, or they don't shoot ordinary high water marks. That's more for the environmental side of things, so that's something we need to go out in the field and establish, which a lot of times we actually have a survey done, and so we can reference actual points on the survey to establish the actual elevation of the high water mark. But this is a very, very simple, basic differential leveling exercise. You pretty much go out right over the pipe, right over the creek, and set a benchmark, which is generally a point. We can either use center line, edge of pavement, a rail on the bridge, something similar to that, but roadway or bridge. And especially if we have the survey, it's a point we know 100%, what it is. Or if it's, if we just have like a DEM, digital elevation model, somewhere we're really sure kind of at least what the average elevation is. Set our benchmark. Again, just shoot a back sight to that benchmark. Establish our instrument height. And then we're just going to take rod readings down in the creek or in a pipe. So these are very, very basic drawings. But for a pipe, what we mean by the flow line is as water flows into the pipe, it's basically the bottom of the pipe. And that's where we need to measure to. So even if it's wallered out down below the pipe, and so say you have a deep cut like right under here, the water still can't enter the pipe until it gets to right here. So that's the flow line of the pipe. Now, if that's the case, then maybe another shot to represent that there's kind of a concave area in front of the pipe would be helpful to the engineer. But that's what we need to shoot. So for a creek, the flow line of the creek is the same idea, but it's the bottom of the creek channel, which is different from the ordinary high water mark. So the ordinary high water mark, which we can discuss more in the field, and it's all based on field determinations, but it's the average kind of water height of the creek within its typical flow regime. So not always the water surface. If it's a dry year, the water surface is probably below the high water mark. If it's a really, really wet time, you've had a lot of rain, big storms, then the high water mark, the water level may be higher than that water mark. So you have to be a little bit more careful when you go out and survey that. But generally, it helps to go, if it's rained, you've had decent rains, but it's been maybe a few weeks or a month since then, and so the water has receded, and so you can kind of see the marks on the creek channel and things like that. But again, you basically just go out and you stick your rod basically where you think it is, and so that's your rod position, and then you take a foresight to that point, and then based on your instrument height, just collect that elevation. And that's pretty much it. So that pretty much wraps up the different surveying, the basic surveying things we need to do. So that's pretty much it for this video series, and we'll come back again next time.